Okay, hi everyone. Thank you all for coming. I'm Vicky Averson. I'm the Principal Data Engineer at Plexure, and today I'm going to be talking about how we've been overhauling the way we bring data into our data platform using this lovely mix of technologies. I didn't get the memo about the rebrand of DLT to declarative pipelines, but just read declarative pipelines. Yeah, cool. So a bit of background. At Plexure, we ingest hundreds of millions of customer activities and transactions every single day. So a bit about what we do. I'm assuming most people don't know anything about what Plexure do, apart from the two people in the room who work for Plexure, and I hope they know. So we work with a very large multinational organization, fast food brand, to provide their mobile application in 60 countries around the world. What this means is in the app, there's targeted offers, adverts, loyalty programs, things like that. So we're kind of capturing the whole of that customer journey from opening the app, looking at an offer, going to a store, redeeming the offer. So this is generating a lot of data, and then this data goes into our personalization engines, which we use to recommend things to the customer, different targeted offers. So they get more things that they want, and then they engage more with the business, which makes the business happy, so win-win. And we also do reporting on how offers are performing so that marketers who run the campaigns can make adjustments so they're performing as they want. So as I said, we're ingesting a lot of data, and we want to do this faster. So what slows us down? So the really obvious thing is we're just not bringing data into the platform fast enough. We've got a lot of kind of infrequent batch ingestion pipelines. A lot of it's legacy. Plexure grew very quickly, and like many organizations that grow very quickly, there's a lot of kind of legacy stuff out there that wasn't necessarily built with the future in mind. So a lot of this stuff isn't really able to run more often than once a day or twice a day, that kind of thing. So one of the things we want to do is move to much closer to real time. And then the other two things, this is one of them, are less about the data speed coming in and more operational, like how we operate as a business. So one of the problems we have is these pipelines are quite brittle in terms of if we make changes to the schema, the fields that are coming in, it can cause issues. So just seemingly innocuous things to some people, like changing the data type of a column somewhere, can cause lots of things to blow up downstream. So just making changes is a bit of a minefield. And then the final thing is, I don't know whether anyone else has this problem, but we have found historically that bringing in new data sets to the platform is actually like a significant piece of work. There's people on one end, people on another end, people in the middle, there's a project, and it just takes quite a lot of effort to make it happen. So one of the things we were looking to tackle is just making that way easier and way more seamless. All right, so high-level solution. We want to use a distributed streaming platform. So something like, we have used Azure Event Hubs, but Confluent Kafka or just self-hosted Kafka would work, AWS Kinesis, one of those platforms. Using Avro serialization for the messages that are going on the streaming platform. Avro is a very efficient binary serialization format that's good for schema evolution. There's lots of support out there with tooling that works really well with it. Alongside that, a schema registry. So this is pretty key to the whole thing. A schema registry is a service where you maintain your schemas for it works with multiple types of serialization, but in this case, Avro. So you maintain your Avro schemas in the schema registry. Schema registries are great for multiple reasons. One is that it provides a agnostic way of interacting with schemas. So for example, our people producing the data are .NET applications, and we're consuming it using Python, DLT in Databricks. But schema registry is something in the middle that is agnostic to both of those things. So they can both talk the same language. And it's also friendly for humans. So I could go into the schema registry and I can see the schemas that are going through the system. So it's a really good way of managing that multiple views of looking at the schemas. And it also, schema registries generally, if you're using one of the common implementations, they will do compatibility checks for you. So if you make a breaking change to a schema, something like changing a data type in a way that's not going to be compatible, it will not let you do that. And then the final bit, declarative pipelines, as they are now called. This is what we're using to ingest the data into the platform. All right, so the flow kind of goes a bit like this. We've got our producers, we've got .NET teams developing applications which will produce data to the Event Hub. They will be developing their code. So imagine they've been told they need to start producing sales data to the Event Hub. They'll be working away. They'll go, right, this is ready for production. This will then go into the CI/CD process. That CI/CD process will publish the schema of those events to the Schema Registry. Assuming that all went well, the CI/CD process will continue and deploy that code to production, where it will start producing events to Event Hub. The messages that go on this Event Hub contain the serialized Avro data, and along with the schema ID for that schema. The schema ID uniquely identifies a schema in the registry, so a certain schema can have multiple versions. That schema ID uniquely identifies that version of the schema. And then on the other side, our DLT pipeline will pick that up, get the right schema, deserialize, and then we'll write to a table in Unity Catalog. And that's the happy path. The unhappy path is if they then want to make a change to the sales schema and they change, for example, a string column to an integer, they'll be developing, they'll go, it's ready, CI/CD process will run, try and register a schema in the schema registry that will reject that schema for being incompatible. CI/CD process will fail. That code never gets to production. So we're massively safeguarding ourselves against problems ever making it to production by using the schema registry at that point. For the rest of the talk, I'm actually going to be talking about the Azure Schema Registry, which doesn't get a lot of love, and lots of people don't even know it exists. But I wanted to briefly talk about the Confluent Schema Registry, which many more people have heard about. There is a really nice integration in Databricks for working with Confluent. So there is, for those of you who don't know, there's a function in open source Spark called fromAvro that you can use to do deserialization of Avro, but you need to know your schema up front. So you pass that schema directly to the fromAvro function. And I'll show that in a subsequent slide. But in Databricks, there is a version of this function where you can pass it schema registry details for Confluent, and then it will go and basically handle everything for you. So your schema registry options look something like this. That third line in the options, Avro schema evolution mode restart, this will basically make schema evolution works. So what happens is, when your pipeline is initialized, when it first starts, the data frame here will have the schema of the latest Avro schema in the registry, and subsequently your table that it's writing to will have that schema. And this is all good, that's exactly what we want, but if this is a streaming pipeline, it's running continuously, and while it's running, a new schema gets registered to the registry, it won't automatically pick that up and evolve the schema in your pipeline because it's running. It needs to restart for that to take effect. So what this property does, the restart property, is when it encounters data that has a schema it hasn't seen before, it'll throw an exception, the job will fail, and you can have it configured to restart. For anyone that's worked with autoloader, it's a very similar thing with schema evolution. If it detects something new, throws an error, restarts. So the reason I bring this up is there is no lovely fromAvro function for the Azure Schema Registry, but we were really keen to get it working, and this was kind of this pattern. The pattern of it failing when it encounters new schemas and all of that was what we were trying to replicate in our setup. So I'm going to do a deep dive. Disclaimer, there's going to be a lot of code, but then it'll be followed up with a demo. So if code's not your vibe, but demos are, then hang tight. All right, so taking schema registries out of the equation to begin with, we just look at the fromAvro function and what that does. So this is what an Avro schema looks like, if you haven't seen one before. And then we can just use fromAvro. We pass the schema into that, and then it deserializes That's all good. That's what it works at the base, how it works at a basic level. But then, obviously, we want to work with multiple schemas. So if we've got a version 1 of the schema here, and then a v2 where we've added a new field, we can create a little dictionary of version 2 schema, and then we can work with it from there. So this is where I should probably pause for a bit and explain how From Avro works with different versions of the schema, because it does do schema evolution, but it's a bit kind of tricky. You can't just pass it the latest version of the schema and it just works. In Avro, there's a concept of a writer schema or a reader schema. So the writer schema is the schema that it was written with, that it was serialized with. And then reader schema is whatever schema that's compatible with that you want to read it with. So in the context of this, our reader schema would be what we want. We would want that to be the latest schema, and that would be what the schema of our data frame and the schema of our table ultimately, but we would always need to pass the exact schema it was written with to be able to deserialize it. So that's the context for what's coming up. The way we're making this work in DLT is we're using the flows API. If you've used append flow before, that's what that is. So we first need to create our streaming table. And then we do a bit of DLT metaprogramming. So we loop through our schemas that we've defined, and we call dlt.append flow. And we're writing to our table that we just created. So what we're doing here, each of those append flows is for a different version of the schema. So we're filtering, assuming we've got a column called schema version in our data, we're filtering that for each version of the schema, creating a flow. They're all writing to the same table. And then the key thing is, so in our from Avro function, we're passing the writer schema, which is the one we need to deserialize, but we're also passing this extra option called Avro schema, which is confusingly named, but we're passing the latest version of the schema for that. So all of our flows will end up with the same schema, which is that of the latest version, but they all are deserializing with the one they were written with. This is the hardest bit of all of this. Everything else just builds on top of that. I'm sorry. That was loud. Right, the Azure Schema Registry. So this is where it gets interesting, because obviously we don't hard code all of our schemas in our code. That wouldn't make any sense. So enter the Azure Schema Registry. This is what it looks like. It looks like what it looks like. I'll show you in the demo later as well. But within the Schema Registry, there's concepts of schema groups. So this is where you group related schemas together. And then each of those schemas has a name, and then each of those schemas has multiple versions. Yes, that is what it looks like. All right, then we need to get the schemas from the schema registry. So instead of that bit where we've got our hard-coded schemas, we need to actually go to the registry and fetch them down. There is a Python SDK for this, but it's a bit limited. It doesn't actually expose all of the REST API calls, and we need more than this is available in that. So I've just created this little client extended. We need to get all the schema versions for our schema, and then we want to get the actual schemas. So then we've effectively recreated what we had hard-coded. I'll just whisk through this. Then putting it all together. So this will look very similar to the version where we'd hard-coded our multiple versions of the schemas. But instead of hard-coding them, we're now getting them from the schema registry. Sorry again. Right, so we first need to read our data from our Event Hub. So you might go, oh, you're reading from Kafka, not Event Hub. If you haven't worked with Event Hub before, it has this really lovely Kafka endpoint. So it just pretends it's Kafka and acts like Kafka, which is a really awesome feature of Event Hub because it means anything that integrates with Kafka can integrate with it. So that's why it looks like I'm reading from Kafka. And then we need to get our schema ID out, so don't worry too much about this. But basically, the schema ID is in the headers of the payload, and kind of nested in this Avro binary thing in the content type header. Then we want to get our latest schema. And then we're basically, this is just the same code we've already seen. So we create our streaming table, loop through all our schemas, append flow, deserialize, filter based on the schema ID. So this is exactly what we saw before with the hard-coded. We just now have our schemas from the schema registry. but we don't have the restart thing. So how do we make the restart thing happen? And this is, we get all our schema IDs that we've seen, and we can add a DLT expectation that if we haven't seen that schema ID before, fail. So this is how we've kind of hacked the restart functionality. All right, so the next problem is how do we extend this to make it like automatically handle new data sets? That problem number 3 I talked about earlier, where we want to make it easier to ingest new data sets. Our vision was, oh, we'd love producers just to start sending us new data sets and to handle that automatically, so no more big projects. And it turned out once we'd done all that work to make the schema evolution thing working, it was actually quite easy to extend it to this use case as well. So this is kind of the picture we're talking about. So we've kind of got producer A, producer B, they're happily already sending data to our event hub. What if producer C comes along, it just starts sending data, and then our DLT pipeline automatically picks it up and creates a new table for that in Unity catalog. So this is what we're trying to achieve. All right, so we just need to make a few changes. So instead of just fetching all the schema versions for a single schema, we're now fetching all of the schemas within a schema group. So we just need a couple more functions. So we first get all the schema names available in the schema group, and then we get all of the schemas for all of them. OK, and then we need to make a few more changes to our pipeline code. So we're getting all the schemas again. We just do a bit of structure manipulation. So I'm whizzing through this a bit because I know people don't like to just stare at code for ages. And then the main change here is instead of just having our one streaming table, we now create one for every single schema name that we have. And then this is exactly the same as it was, pretty much. I think we maybe moved some things around. I think later schema is now nested within the function. But it's basically the same thing. We're just writing to the specific table name that we need to. So yeah, this is the crux of it, really. Create the streaming table for each schema name. And then, yeah, do our append flow metaprogramming. Demo, yay. So, yeah. Right. This is where it gets exciting. Praying to the demo gods that everything is going to work nicely. All right, so I've got my little demo notebook set up. So this is our scenario that we're trying to show. My pipeline's running. So it's first ingesting just the raw data from the event hub. This is not deserialized. This is just the binary data and all the event hub metadata as well. Right, I'll get running. I just need to do some initialization installs. I'm setting up my Schema Registry client. These are Azure provided libraries. Avro encoder, again, this is provided by Azure for encoding using a Schema Registry. And the Event Hub producer. So this here is this is my data producer notebook. All right, so the first thing we're going to do is register a new schema. And this is sales data that looks a bit like this. Cool, so I'm just going to run this. I'll show you the schema registry first. I don't know why I need to do this. I just feel like, in magic tricks, we're like, oh, look, it's perfectly normal deck of cards. But yeah, there's nothing here. Right. All right, so I've sent my schema to the schema registry. So this would be like that CI/CD step where it's doing the registering. All right, so we've got our schema here. We can see it in here. I could probably see it a bit better if I open it up. Yeah, all right. Fun fact, you can document your Avro schema. This will be relevant very soon. But it's a really nice feature within Avro. Cool, there it is. Still not doing anything because we haven't sent any data. And this is where I hope and pray that everything works as expected. Cool. Right, we're going to start sending some records. So we're here, we're in the producer. We're going to get the schema from Schema Registry, and we're going to start sending those events to the Event Hub. So we're using the Azure libraries for encoding and sending. I'm just going to send 4 sales records to the Event Hub. Now, what we're expecting to happen here is the expectation will fail because it hasn't seen this schema before. It takes kind of an annoyingly long time for this to happen, which I wouldn't mind normally, but when you're doing a live demo, it's just a bit anxiety-inducing because you're wondering whether it's going to work. So, fingers crossed, in several seconds' time, this expectation will fail. And we will be able to see what happens. Yay! Okay, that's a relief. All right, so we can have a look at the expectation. I don't know how well you can see on those screens, but it basically says, failed to meet the expectation, violated expectations known schema, and then some more information. Classic expectation stuff. Sorry, I'll just pop this away because it's taking up the screen. All right, so this should be now restarting. If anyone's done continuous pipelines with expectations before, you might know that, I'm just preempting random questions, you might know that it doesn't actually automatically fail. It kind of just keeps running, even though the data set has failed the expectation. I have a little watcher thing that's looking out for the pipeline events for when the expectation fails, so I then restart the pipeline. Anyway, look, happy days, it's worked. So we now have our sales data coming through in our pipeline. Cool. The next thing, you can try to evolve the schema in an incompatible way. So what I'm going to try and do here is, change one of the data types. I think this was a string to an integer. So I'm just going to try and register that in the registry. All right, we get an error. Avro schema, don't try and help me. Avro schema validation failed. Backward compatibility test failed when checking against schema sales, version 1. So this is what we want to happen. This is our CI/CD process going, no, you can't do that. We're not putting that code into production. All right, now we want to evolve the schema in a compatible way, which is just adding a new field. So if we create a field called new field, it can be null. Its default value is null. And then we add it in. There we go. We can add that new schema to the registry now. Cool. So then we should see in the registry, right, we now have 2 versions of the schema. So version 2 has this new field in it. Again, this hasn't done anything because we haven't actually sent any data, but then we shall send some. All right, so I've sent 2 sales records with the new schema to the Event Hub, so now there's a bit of a wait for it to fail again. In the meantime, we can have a look at Unity Catalog. So our table is in the catalog here. All right, this is a little fun bonus that I didn't talk about in the presentation because I thought it was already quite a lot of slides. But we've got kind of what I call auto documentation. So if you remember from our schema that's registered in the registry, we've got these little docs. There's a doc on the record itself. This is kind of like the doc for the whole event. And then we've got little docs on each of the fields. So what I've done is taken that and made that go into Unity Catalog as documentation for our data. This is really cool for us because the people producing the data are the ones that really know what that data is all about. So they're the best people to document it, and then that way they're documenting at the source, and then we get it, and it's in Unity Catalog, and it's great. I can show you how we do this. It's just a bit of utility. So if we go, here is my pipeline code. This is literally what was in the demo, so it should hopefully look familiar, but this is the magic. So when we're creating the when we're creating the streaming table, we can pass a comment, which is the table comment, and can specify a schema. And this schema, this is a struct type, but you can specify comment metadata in that struct type. So I've got a couple of little utility functions for this. If we go in here, oh look, more code from the demo. It's real. Yeah, get table comment, we're just getting the doc out of the Avro schema. Getting the column comments is a bit more complex. We need to create a struct type based on the Avro schema. The easiest way I could find to do this was just to kind of use Spark, kind of read format Avro, nothing, but you get a schema out of it. And then get the comments from the Avro schema, and then add these as metadata to our struct type, and then return that. So this is what's going into here. So that's how the auto documentation is working, which is pretty cool. Anyway, this restarted. We got our new evolved sales coming through. Then we want the interesting bit, which is registering a new schema. So we've got some clickstream events this time. All right, I'm going to register a new schema in the registry. This is a completely different data type now, not a different version of sales. It's just a completely new one. And then I'll start sending some events. All right, so while we're waiting, we can have another look at the schema registry. Yeah, so we've got our new event type here. Kind of looks the same. This has now failed. G'day. It's coming. Sweet, so now we've got 2 data sets coming off. So now we're automatically producing 2 different tables. Yeah, we've got our clickstream events coming through nicely. So one of the things I can start sending some other sales. I can also send the old version of the sales, and that'll work fine. So this is the original schema. So we'll read with, this is where the reader-writer schema comes in. Here we'll be reading with the latest schema, but we'll actually be deserializing with the one it was written with. All right, so we sent some more events. They should just come through. Yeah, look, 6 popped up here. Yeah, and we've got some records here. So we've got everything going to the right place, which is fun. Have another look at our tables. And we now have, our clickstream events here as well. Start having a look at what's in here. Yeah, we sent 2 records here. Sales, we've obviously got quite a bit more. And, how do I see over there? For some reason, I don't seem to be able to see. Oh, there we are. So new fields. So we only actually sent 2 that have that. 4 of these predate when we evolved the schema, and then I just sent 4 more with the old schema again. So that's why they're all coming through with nulls. And if you're interested, we can have a look at the raw data, which doesn't really tell us anything. But this is the magic. This is the value. This is our Avro binary serialized record. And then there's some extra metadata here and the schema ID. Cool, so that is it for the demo. I'll just go back here. All right, so the key thing is, have we actually solved our problems? So yes, no more infrequent batch ingestion. This can be done near real time. Well, the point is it's up to us now, so if it doesn't need to be near real time, it can be as often as we need it to be, but it can be near real time. Evolving schemas is risky. Our schema registry has helped us with that because we've now got guarantees when a new schema is being registered that it will be rejected if it's not compatible, and the CI/CD process, the producer, will fail, and it will never make it to production. Happy days. And bringing new data is a significant piece of work. No, because producers can just start sending new records to the Event Hub, and we'll automatically pick it up and create tables within Databricks. So it's very exciting. And that is it for my presentation. Thanks very much. I'll be happy to take questions. I think we do have some time, so if there are any, happy to answer.